G'day viewers, I'm going to try overvolt with a variac. This light, as I said in the previous video, this filament here is popped. It's not really much use to it, me anymore, or anyone else who may need to use it, so got plenty of replacements anyway, so I'm not only going to throw it out, so I'll just see how much voltage it takes to pop that. Got an amp meter hooked up, rectified of course, bridge rectifier. Cats want to join in on the action. Alright, that cat's having a nice sleep, so let's see if I can get this grabber go pop. It's on 0, turn it on. 1 amp. That is hell bright. Still chewing 1 amp of power, it's on 20 volts, but something I didn't mention in the previous video, when it's rectified, the voltage is obviously higher on the output. There you go. Surge current of 2 amps to blow that filament. It just melted it. I wish I had a better camera. But yeah, that filament surged up at 2 amps and I had it around about 30 volts. Which I think it's 9 or so volts higher on the output when it's rectified. Got a bit warm. But yeah, about here I got the surge, so wasn't too much load in the variac, which is good. As you can see, it's just, yeah, not bad. Got hell bright though. So it's a 60, 50, that's actually a 55 watt H4. But yeah, that was pretty interesting. So I'll go get some more little, I found some more little knickknacks to pop too. I got a couple of old computer CD drives I forgot I had, which is stuff. So I'll get the motors out of them and we'll pop them and see how they go. So yeah. Okay, viewers though, we've got more stuff to pop. That glabber's still a little bit hot. Take that out of the circuit there, unhook that. Yeah, top filament's already open circuit, so yeah, it's gone. That can be chucked out. Negative, positive there, so I've got to get the polarity right here before I go any further. And I've got this cheap, nasty Chinese DVD player. There's a DVD player itself that had like a control board or the software and stuff on it, which is a part in all cheap DVD players that always goes wrong. It's just made by Fuss Audio DVD drive. It's a Zhong DEH Electronic Factory. Xing Da King Long Dong Long Gang, Shenzhen, China. It's basically a computer DVD drive that's modified to go inside of and made into a circuit that's, yeah, an ordinary DVD player you plug into your TV. Had lots of awesome features, I'll give it that. Much better than what better brand DVD players have, but because it's a cheap DVD player, it had that stupid inbuilt defect which makes them skip chapters and then eventually not play discs at all. That matters when I get the variac. That one there, I think, yep, that's the right top. That's going to get the variac. Because I don't have any much use of these little motors. And that one is going to get the variac. The laser assembly is fine. I might just keep that because of the laser diode. So yeah. Now which wires are which here? I'll start with this tray mechanism one. One that opens a tray, the disc tray motor. Untangle this one. Always have an amp meter in series of the circuit just so I know what's going on. Keep track of current draw. Pretty handy. Fine there. Try and keep that in view of the camera so you can see that burn out and that at the same time. We'll final check so that's all connected. Nothing there, it's going to go wrong. Put that mid-way so I can see whether it's going to open or going to close. Let's try that on 0. Turn it on. $20 volts. 40. 60. No, it's not, yeah. It's a little bit higher on the output, so. Because it's rectified, I don't know what the voltage really is. Some grease flung up on there too for a second. Got some speed, but it didn't actually surge any amps, so... Phew, that stinks. Ooh, that made a nice arc, but it stinks. Yeah, she's dead. I haven't got time to unscrew them and set them on their own so you can see the destruction, but the advantage of having it in there is that when it kicks, it's got something to support it, so it's not going to kick you in and short out anything. So it's a major advantage of having it like that. So I can, like I said, the mechanism working, it's more interesting. There's a little spring here that slips like a little clutch. It's pretty interesting little design. So there's actually grease flinging up here, building up here on the cog, which I didn't even know there was grease on in the first place. So that's how fast it was spinning. Big film of grease. So try. Let's see this one. Oh no, that's the that's actually the carriage assembly motor, not the tray eject. That's the tray eject one there, which is the grey and orange wire. That one there. Right, hope that's a good connection. From 0. It's much more fun way of having destroyed stuff instead of just throwing out something you don't need complete. Just keep your old parts. Parts like this that you don't want or you may not need. I have a load of it, makes a good funny laugh. Makes for a good laughing video, I mean. Okay, well that one is not actually working, must have a bad connection. Okay then. Alright, I'll start again, turn this off. We'll try and get this, strip this wire down some more. Let's do it like this. There we go, that's better. There goes there, we've got the wire go on there, so. Alright, now it should work. It's a better connection now. 0. Push it back in for a second. That wasn't very interesting, that one. Didn't last long at all. Yeah, it's just seized. I can't get it to... She's seized, doesn't move. Alright, switch off, we'll do another pop. That motor didn't last as long as I was expecting it to, so let's try this one final motor. I wonder if I can put a disc on that before I blow it up. That might make it interesting. Put a little old DVD or CD or something on there. See how fast it spins before the motor starts to burn out. So yeah, we'll try that. Okay viewers, get one of those protector discs you get from DVD spindles. When you finish them you get this little disc. I think there's one on the top or something, or one on the bottom of some batches I get. That's just some sort of protector disc with no metal data film on it. I'll try and work the mechanism from there to lift this back up, which I'm seeing with a jam with that motor. To fix that I'm going to have to take that fan belt off, so I can slam the tray in, which will build up momentum to close the disc under the drive. I might keep that belt, it might come in useful for something. Yeah, that motor's seized. If I slam this hard enough, no. I can pull it apart and get that thing to clamp on. I might just do it from here. There you go. That's better. Just did it from here. Push that and it's clamped the disc on. That there and that there. Those two wires there, so I'll pull them out. You'll obviously see sparks flying out from the bottom of that, but yeah, not all motors do that. I just do it from this angle so you can see this spin. Might be more interesting. We'll do our redneck way to strip the wires here. Just get the clamp and just go rip. That's fine. Twist that around there. That's the second one done. Alright, make sure they're not touching or shorting out. Set that there. Nothing shorting out, so we're good. Oh, it's on 0. That's all connected up. The disc's in so they can spin. Alright, let's try this one out. Momentum, it actually popped. That wasn't as interesting as that first motor. Didn't even surge any amp, so that's probably the advantage of popping small 4 volt motors. It's not going to put much load on anything when they pop. Barely even got warm. As I keep saying, I can't stress enough before you touch anything and make any adjustments to your connections. Otherwise, make sure your power's off. Yeah, the motor turns, but not properly. Yeah, I've blown that motor up. Anyway, that's probably enough. I'll try and, yeah, that's enough of that stuff. So, yeah, thanks for watching.